Okay, so we're doing chapter 9, problem 35. So we have a 0.45 kilogram hockey puck moving east at a speed 4.8. Ooh, I wrote this wrong. So that should be 4.8 meters per second. And it has a head-on collision with a 0.9 kilogram hockey puck that's initially at rest. Assuming that this collision is perfectly elastic, what will be the speed and direction of each object after the collision? Okay, so we can use equation 9.8 in the book, and this will give us a relationship between these velocities. So what this tells us for an elastic, perfectly elastic collision, that V1, our first guy, the velocity of our puck, minus V2 needs to equal negative V1 final minus, I put an extra negative sign in there, my bad guys. This should just be V1 prime minus V2 prime. Okay. So since we know that V2 initially is 0, then this just tells us that we can write V2 prime as V1 plus V1 prime. Okay, so now we can go to another equation, which is the conservation of momentum. So that tells us that m1 v1 plus m2 v2 needs to equal the same things with the final velocities. Okay, well we know v2 again was 0, so that part is okay. And then we can plug in what we have for v2 prime. So what we get then is we have m1 v1 equals m1 v1 prime plus m2 v1 plus v1 prime. Cool. So now let's rearrange this and solve for what v1 prime is. This turns out to being m1 minus m2 over m1 plus m2 times v1. Well, we know all these things, so we can now plug this in. So this is 0.45 minus 0.9 kilograms over 0.45 plus 0.9 kilograms times 4.8 meters per second. And that comes out to being a v1 prime of negative 1.6 meters per second. And this negative sign in our coordinate system, if we were initially going in this direction, they said that was east, so negative is the opposite of that. So that means this is 1.6 meters per second to the west. Cool. So now we need to find v2 prime. v2 prime is v1 plus v1 prime. So that's just 4.8 meters per second plus negative 1.6. And that's 3.2 meters per second. Since this is positive, it's in the same direction as v1, so that is the east. Cool, that's it.